So what we're going to be learning about today is something called dimensional analysis. In a lot of ways, it's like the algebra you probably already know about, but it's a way of using algebra that'll have wide application, not only in science, but in many things you're going to do in life. So the word we're looking for here are the words dimensional analysis. And it's just a process for kind of making sure that your math is right, the kind of math that we do in a chemistry class in high school. Okay? And so to sort of tie it into the things you already know, you know in algebra that if you have 3x over 1 times 4y over 2x, you probably know how to solve that already, right? Does that make sense? Okay. So 3 times 4 is 12, and you get x, y. And 1 times 2x is 2x, right? But there's some more simplification to be done. Huh? What's the simplification you can do here? We couldn't divide by 2. Okay. There's one more thing you can do. The x's are going to cancel out. Okay? Good. Those are going to cancel out. And we're going to divide, those by 2, right? Top and bottom. Whatever you do to the top, you have to do the bottom to keep it. And it has to be multiplication or division. It can't be anything else. Okay? And the result is we get 6y. Yes? Well, suppose instead of going over here and canceling the x's, we cancel it over here instead. Let's do that. 3x over 1, 4y over 2x. And we simplified it before we started. My time sign didn't look so good here. Okay, so x cancels out here. Okay? And we'd be, part of the way there. We wouldn't have to write the x on the other side. Does that make sense? Well, that's kind of the basic idea behind dimensional analysis. It's just taking something you already know, which is you have to cancel out those x's, or let me put it this way, you should know, okay? And that's what that you're going to use that knowledge. Now, here's what's going to happen in a chemistry class, is that units of measurement and chemical species are treated like x's and y's in algebra. Helps when I can spell. That word is algebra right there. Okay? Okay. Let's say I have 12.0 grams of iron. Now, you might not know this, but the symbol for, anybody know the symbol for iron? Some of you said Fe, good. Some of you had to memorize those, okay? We're not going to memorize them, but the more you use them, the more you know them. Okay, and iron we use quite a bit, so you should know that's probably right. All right, grams of iron. And what we want to do is to convert that to the volume that 12 grams of iron would have. Well, for that we need density. Turns out the density of iron is about 7.86 grams per milliliter. Okay. When you need to see something like that, you need to know that when you put grams per milliliter like this, it also means 7.86 grams of iron over 1 milliliter of iron. Okay? Just got to know that. And when you see this, because it means that, it means for that iron, at around room temperature anyway, this amount of iron, 7.86 grams of iron, equals a milliliter of iron. Yes? Over a milliliter. Oh, here? It's 7.86 grams Fe over 1 milliliter of Fe. Okay? Yeah. All right, now, here's the really important thing I'm trying to get to. This is one thing that you always need to know. Okay? If you have the density of a substance written in a fraction like that, okay, it means that, what it means is that this amount of iron is equal to a milliliter of iron, assuming normal average conditions, okay? Oh, wow. I did that 100 times. I didn't do it once out of 100, I'll bet. Okay. Got that? This is important. And this is called, big word here, equality statement. Not really a big word. It just means two things are equal, okay? It's a mathematical statement saying two things are equal. An equality statement, okay? You need to know when I say an equality statement, that's what I'm talking about. All right, we're building up to the big finish here, okay? The way that we're going to convert in here, we're not just going to take a number and stick it in there and plug it in and multiply or divide, because that doesn't tell you what's really going on. I want you to know what's really going on so you can use this in bigger and broader ways in the future, okay? And that's the important thing, because we're going to be doing math in this chemistry class where we have to do, we'll fill up a page and a half of calculations on one problem, and you'll be able to do it. But you've got to first know the little things. If you can do this and the thing I'm about to show you, you can do all this stuff, okay? And it's just you got to do the small stuff first, baby steps first, right? Okay. Now, here's what we're going to do. If we're going to do a conversion in this class, for me, you always have to have an equality statement first. You have to write it out. Got it? And future classes, after this one, they might not require you to write it out. Okay? What I want you to know is where we're going to get what we're doing here, it comes from this. I mean, it's just that important, and this is going to be a thing that years from now, you probably won't even remember that Mr. Tedder taught you this, but it'll be there in your head, and you'll be able to use it. Okay? All right. So if I want to convert this into milliliters, and that's the question, okay, what I want to do is I want to convert .0 grams of iron to milliliters, okay? I could put it in the form of a question. If you have 12.0 grams of iron, how many milliliters do you have? Does that make sense? And that's really probably the direction you'll go in later on. Where did that one drop? There it is. Okay? All right, here we go. First step, put your starting amount over 1. Okay, step 1. Put starting amount over 1. What is a starting amount? A starting amount is something that can stand alone in the problem. All right? It's a measurement of a given substance or stuff. Okay? Put the starting amount over 1. So this is our starting amount here. We're going to put it over the number 1. Step 2. create an equality statement. To relate the starting units and species to ending units and species. Okay, now what's a species? In this case, it's the chemical element. It's whatever the chemical is or stuff we're starting with, okay? Not how we measured it, but what the stuff is, okay? So in this case, our starting species is iron, and we're going to end up with iron, okay? We're not going to change from iron, so the ending species is going to be iron just like the starting species is. Got that? All right. Step 3. Build a conversion unit from the equality statement. ES, equality statement, okay? And the way you're going to build that is with units and species matching the starting amount on the bottom. Okay, build a conversion unit from the equality statement with units and species matching the starting amount on the bottom. Kind of a complex sentence here, okay? But it's a really simple thing, okay? You got that? Can I slide back up there to the problem now? No? No? Please no? No. Thank you. That's so much nicer. Build a conversion unit from the equality statement with units and species matching the starting amount on the bottom. All right. Are you good for me to slide up now? Okay. Here's what we're going to do. I'm going to do times and have that little bar right there that shows where we're building a fraction. And I'm going to look at the equality statement and look at which side of this equality statement, left or right, has matching units and species to that starting amount. And it's this side, right? This has the same units as grams and species of iron. That's the one I'm going to put on the bottom. So 7.86 grams of Fe goes on the bottom. Okay? And a conversion unit has stuff on the top and the bottom. Okay? So I want to put the other side of the equality statement on the top. All right, big finish here. What did we say about x's and y's? They cancel out, right? You have them top and bottom, and you cancel them out. We're going to treat our units and species just like that. So what can I cancel in this problem? Grams can cancel. Anything else? Iron can cancel too. We're going to treat units and species like that. Now for me, I want you to show this being crossed out with a single line, okay? So I know you know what you're doing. Does that make sense? Okay, it's a real simple thing, one line through there. And as we get to more complex problems, it's kind of going to be important to mark them out so you can keep up with it all, because you're going to have a lot to do. And if you just do it in an organized way, it's going to be easy. Okay, well, here's where you need a calculator. And everybody should have a calculator today. All right, everybody got the calculator out? All right, so up here, we waited till we got to here to do the division, didn't we? All right, but we could have done the division here and saved this step. How do we do that? 3 times 4 divided by 2. It's better to, in fact, it's necessary that you take this and multiply by that, hit equals, and then divide by this. You with me? Of course, we're multiplying by 1, so what are we going to get? Yeah, so we'll get the same thing. In this case, we can skip that step and go straight to 12 divided by 7.86. Does that make sense? If there were some other number besides 1 here, you take this number, multiply by that number, hit your equals or enter key, then divide by this. Okay, but in this case, we can go straight to that. So 12.0 divided by 7.86, and we get a long number. Okay? Now, I don't know how you've been taught to do that in math classes before, but for us, I want you to show me that full number. And your calculator may not have as many digits as mine does. That's okay. You write down the number of digits that are showing on your calculator. Okay? Now we've canceled grams and canceled iron, but we still have milliliters and iron left, so we need to write that over here. Milliliters of iron. Last step is to round off. Okay? Anybody know how to round off when you've multiplied and divided? No? Okay. Did somebody say yes? Nobody knows. Huh? Okay. Don't know how to round?
No, I didn't think
You know how to round, but do you know what the rules are that apply to this kind of math? Okay, here's the deal. Look at the problem. Ignore the single-digit things like this that are counting numbers, okay? Because this is like, you counted 1, all right? This is like we put a 1 down there, it's just a 1. Well, those are technically infinitely significant. We don't worry about it because I could put a million zeros for decimal place. It'd still be 1, all right? But these numbers have a certain number of significant digits, and the significant digits are 1, 2, 3, and 1, 2, 3. We want our final answer to have the same number of digits as the measured or calculated number with the least digits. And this is a measured number, and this is a calculated number. Okay, let me go through that again. When you're doing multiplication and division, you go through the problem, ignore the counting numbers, and of the measured and calculated numbers, find the one with the least significant digits, round your final answer to that same number. So 1 digit, 2 digit, 3 digits, we're going to underline from here over. Now it's required in this class that you underline to show the insignificant digits, okay? To show the insignificant digits. And to show that you're rounding off, you can't put an equal sign because this is not going to actually equal the number we're going to have at the end, okay? And you can't use squiggly equals because that means something else. It means you're estimating. It doesn't mean you're actually rounding, okay? We're going to use an arrow to show a rounding off, okay? It's required that you show an arrow to show that you round off. So what's our final answer going to be?
1.53.
Really? There's a 6 here? Yeah, 3.
1.53.
1.53, okay. Now, in college, there's actually a better way to round than this, but this is what you've been taught all through school. We're going to stick with that to make it a little bit simpler. We've got enough to do already, all right? We're going to stick with that. So 1.53. Okay. Let me ask the answer. Now we're going to do this so much in here that it's going to be, if you're careful in the beginning to follow this step-by-step procedure, okay, you're going to find that, this is going to be like you're going to do it in your sleep. It's not going to be a problem. And I'd prefer if you would put a box around or a rectangle around your final answer so when we get those really complex answers later on, complex problems later on, I can find the answer in all those other numbers you got on the paper. Okay? Is that good enough? You good? Okay. That's what I want you to do. All right. So let's let you practice now. You ready to practice? I'll let you work with somebody around you. Okay, you can find a learning partner. Okay, if you want to, or you can do it by yourself, whatever you think. So here's the problem. All right, what we want to do is go through this problem and find the measurement that stands alone, okay? And that's the 17.5 grams of carbon, all right? Because that's the one that says how many of this are you going to get from this. Does that make sense? So that you got to read the problem and kind of interpret it, or not kind of, you got to actually interpret the problem to find the thing that stands alone. That's your starting amount. So our starting amount here is 17.5 grams of carbon. So that starting amount is what's going to go over 1. And then we're going to build an equality statement from the statement, the first sentence up here. That's required. The equality statement is that there are 12.0107 grams of carbon in 1 mole of carbon. So that means that many grams equals 1 mole of carbon. Okay, so that's our equality statement. Now we're ready to build the conversion unit. We find the side of the equality statement that has the units and species that match what we're starting with. That side of the equality statement goes in the bottom. And then we're going to put the other side of the equality statement on the top. And we're going to do the math. Whoop. Move my emulator over here. Okay. So we want 12 point, let's see, we're going to take 17.5 and we're going to divide by 12.0107. Okay. Hit enter. All right. So we want to cancel out the units we can cancel out. That one goes away. The species cancel out, carbon and carbon. We're going to look at these two numbers and find the one with the least digits. This has the least digits, and that has 1, 2, 3 digits. We want 1, 2, 3 digits here. These are underlined. We're going to keep our remaining units and species here, moles of carbon. Okay, we're ready to round it off now. And so I get 1.46 moles of carbon. And I put it in the box to show that's the final answer. How'd you do? Figured it out after a while with a little help. Okay? That's fine. No, it doesn't matter. It doesn't matter. You put down there what your calculator is showing. Okay? Yep. It doesn't really matter where it is, as long as it's there. Okay? All right then, let's try. I'm going to give you a work problem to work as homework.